Outlines can be used in both 2D and 3D games to emphasize specific objects in your scene. We can use shader graph in order to create outlines in 2D, taking advantage of the 2D graph presets that are provided by Unity. In this project, we will be using the Bandits pixel art pack, available on the Unity Asset Store, and the source of this project will be available on GitHub. Both links are in the video description. There is no option in the Unity Hub to create a new 2D project using Universal Render Pipeline, so instead, I've chosen the 2D preset, and we are going to install URP ourselves. Go to Window, Package Manager, select all packages, and search for Universal RP. Once it's installed, we need to create a new pipeline asset in order to utilize URP in this project. Go to Create, Rendering, Universal Render Pipeline, Pipeline Asset. I'll just call mine Default Pipeline. This creates two assets, one which contains all the settings for the pipeline, and one which contains all the settings for the renderer. It's a little bit out of the scope of this video, so we'll use the default settings. Go to the Project Settings window, I usually leave mine docked next to my inspector, and open the Graphics tab. Then drag the pipeline asset we created onto the Render Pipeline Asset slot. Our project is now set up to use URP. If you want to make the most of URP's 2D features, I'd also recommend replacing the forward renderer with a 2D renderer, but that's not required for this tutorial. Let's create a new graph by going to Create, Shader, 2D Renderer, Sprite Lit Graph. You can also use a Sprite Unlit graph if you'd like. Then, open the Shader Graph editor. To begin, we'll need to sample a texture inside this graph, so add a new property and name it Main Texture. If we give it a reference value of main text, then Unity will apply the sprite from a sprite renderer to this property automatically, which is especially useful if the sprite is animated. We'll drag this texture onto the graph and connect it to a sample texture 2D node. We're going to use the alpha channel of this sample to decide whether to draw the sprite unaltered or attempt drawing an outline. Create a new comparison node from the alpha channel and set its mode to greater or equal, then set the second field to 0.5. This is going to output a boolean value of true when the alpha is set to at least 0.5 and false otherwise. Then, we'll add a branch node using the result of the comparison as its predicate. A branch picks between one of two sets of nodes based on the boolean value of the predicate, so attach the RGBA of the sample texture 2D node to the true field. The false field will be fed the result of the outline calculations. The result of this branch can then be connected to the color field of the Sprite Lit master node. In order to detect where to place the outlines, we're going to sum up the alpha values of the adjacent pixels. We'll have two modes, one that samples in the four cardinal directions only, so up, down, left and right, and another variant which samples 4 more times along the diagonals too. Our main graph will get messy if we add the nodes required for all 8 samples, so we're going to encapsulate the logic for one of these samples in a subgraph. We can create one by going to Create, Shader, Subgraph. I'll name mine Outline Sample. The only thing you should see is an output node. Click the cog menu and add a new vector 1, which we'll call alpha. That's going to be the only output of the subgraph. We also need some input properties for this graph, so add a new texture 2D, called texture, and drag it onto the node. Then, use a sample texture 2D node to get its alpha value, which is then output. To sample in different directions, we need to modify the UVs for the sample. Add 2 more properties, a vector 1 called outline thickness, and a vector 2 called direction. I hope it's fairly obvious what they mean. We want to displace the UVs by a number of pixels equal to the outline thickness, in whatever direction is passed to the subgraph. To get the size of one pixel, we can use the texture's texel size, construct a new vector 2 using the width and height values, then use a reciprocal node. The texel size gives us the resolution of the image, so taking the reciprocal of the resolution gives us the size of each pixel in UV space. We can then multiply by the outline thickness, then multiply again by the direction. This all gives us an offset value. Finally, we can create a UV node and add it to the offset, then plug it into the UV parameter. Our subgraph should now be complete. If we hadn't created the subgraph, then we would have had to create all these nodes on the main graph 8 times over, so this is definitely going to make the main graph easier to navigate. Go back to the main graph and add a new property called outline thickness of type vector 1. We'll use this when we use the subgraph. Also add a color node called outline color. It doesn't matter much what the reference values are, but I like to keep my project organized. We can use the subgraph as a node by searching for its name in the Create Node menu. We'll start with the 4 samples in the cardinal directions. Each one will use the main texture and outline thickness as inputs, but the directions will differ. We'll use the values 0, 1, 0, -1, -1, 0, and 1, 0 for the 4 nodes respectively. We need to then sum the alpha outputs using add nodes. Throw in an extra add node but leave its second value as 0. We're going to connect the corner samples to this node later. After all those additions, use a saturate node to clamp the value to 1, or else the colours might end up a little strange. We're going to construct a new colour, although there isn't a node for that, so we'll use a vector4 node instead, and the RGBA colour channels correspond to the XYZW components of this vector4. The saturate node feeds into the W component, and we can use a split node to separate out the red, green and blue colour channels of our outline colour and connect those to the XYZ components. This vector4 then connects to the false field on the branch we created earlier. We can test this out right now by creating a new material, which I'll call Outline Sprite, then select the appropriate shader using the drop-down. Choose Shader Graphs, Pixel Outline. Now we can drag this material onto both sprite renderers and they should receive an outline. Now we'll add support for corner sampling. We'll make this a shader feature so that we can switch it on and off at will. So add a new keyword of type boolean and call it sample corners. If we use a reference called corners_on, this will appear in the inspector. If we don't use the _on, it won't get exposed. We can add 4 more outline sample nodes in much the same way as we did before, but using 4 different directions. This time, use 1, 1, -1, -1, 1, -1, and -1, 1. Add them together like before, then use the sample corners node. When the feature is turned on, we want to use the result of all those additions, so plug them into the on field. Otherwise, we want to add nothing, so leave the off value at 0. Connect this to the add node we previously left open. If we make sure the feature is turned on, sometimes you need to tick the box a couple of times to force Unity to recognise both shader variants, we'll have our full outlines, corners and all. That's it for this tutorial. As always, I'd like to thank my Patreon supporters. You really do help me keep making content like this. I suppose I wouldn't be a real YouTuber if I didn't ask you to like and subscribe if you learned something today. Thanks for watching.